Okay, so let's get ready for a showdown. An epic battle between two forces that literally shape our entire reality, light and sound. Now, you might think they're similar, right? They both travel in waves, they carry energy, but trust me, they play by a completely different set of rules. And it all really boils down to this one classic question that I'm sure you've wondered about. Why do you always see the flash of lightning before you hear the boom of thunder? Well, that simple little observation, that's the key. That holds the answer to the huge differences between these two things. So let's dive in and solve this mystery together.
All right, first things first. To really get our answer, we've got to go back to the absolute basics. I mean, we call them both waves, but honestly, they might as well be from different worlds.
So first up, let's talk about light. What even is it? Well, it's an electromagnetic wave. Think of it like a ripple, but not in water. A ripple in the very fabric of the universe itself. It's created when charged particles, like electrons, get all shaky and vibrate. And what's super weird about light is that it's got this dual personality. It also acts like a particle, zipping around in these tiny little packets of energy we call photons.
Okay, now for sound. And sound, it is a completely different beast altogether. It's what we call a mechanical wave. And that word mechanical is key. It means it absolutely needs something physical to vibrate, like a guitar string or the air pushed by your vocal cords. Sound is just the energy of that vibration getting passed along from one molecule to the next like a chain reaction.
So here's the bottom line, the first big takeaway. Light, that's a vibration of invisible fields. Sound, that's a vibration of actual physical matter. That one single difference, that's our first huge clue. And believe me, it changes everything. Okay, so we know what they are. Now let's look at how they actually get around. Because they're so fundamentally different, it makes sense that they follow totally different rules for traveling through the world.
All right, so light travels as what's called a transverse wave. The easiest way to picture this is just imagine you're shaking a long rope up and down. See how the wave moves forward away from you, but the rope itself is just going up and down, right? At a right angle. That's light. Now, sound is totally different. It's a longitudinal wave. For this one, think of a slinky. If you push one end, you see that compression, that bunching up, travel all the way to the other end. The vibration is moving in the exact same direction as the wave. It's a push, not a wiggle.
And this right here, this leads to a really critical, game-changing difference. Because light is just a vibration of fields. It doesn't need any stuff to travel through. It can just zip right through the total emptiness, the vacuum of space. That's how we get light from the sun and all the distant stars. But sound, remember, it's a vibration of matter. It has to have a medium. It needs molecules to bump into each other to pass the message along. And that, of course, is why in space, no one can hear you scream. There's nothing for the sound to travel through.
Okay, now for what is, I think, the most dramatic part of this whole comparison. We've got different types of waves, they have different travel needs, check. But when we start talking about speed, oh man, it's not even a competition. It is a completely, totally unfair race.
And really, these next two numbers, they're going to solve our whole lightning and thunder mystery once and for all.
First up, the speed of light. Get ready for this. 300 million meters per second. That is the cosmic speed limit. It is the fastest anything is allowed to travel in our universe, period. It is just mind-bogglingly fast.
And then we have the speed of sound. It's a respectable 343 meters per second. I mean, for us on the ground, that seems pretty fast, right? But in this cosmic race we're talking about, it's barely even moving.
Let's try to put that massive difference into perspective, because those numbers are just huge. Okay, so in the time it takes you to just snap your fingers, like 1 second, a beam of light could circle the entire Earth 7.5 times. That's insane. In that same single second, sound would have only traveled about the length of 3 football fields. I mean, it's not even close. Light is almost 1,000,000 times faster.
So all these incredible differences, they're not just fun trivia facts, right? They lead to completely different ways we use light and sound every single day to, shape our world. So, for example, both waves can bounce off stuff. We call it reflection. When light reflects off a smooth surface, like a mirror, you get an image. When sound reflects off a big surface, like a canyon wall, what do you get? An echo. It's pretty much the same principle, but with totally different results. Okay, here's a really cool one, polarization. So remember how light waves wiggle up and down, side to side? Well, because of that, you can actually filter them. You can block all the wiggles except for the ones going in a specific direction. That is exactly how your polarized sunglasses work. They cut out the horizontal glare.
But sound, remember, it's a push, like a slinky. You can't really filter a push that way. It just doesn't work. You can't polarize it. And these unique properties give light some truly incredible superpowers. I mean, we harness its speed and focus energy to make lasers. We use its ability to travel through glass to send the internet through fiber optic cables. And of course, it's the entire basis for our vision, for astronomy, for solar power. The list goes on.
But hey, let's not count sound out. It has its own amazing set of superpowers too. Its ability to travel through materials is essential for, well, communication and music, but also for things like sonar, which maps the ocean floor, and ultrasound, which lets doctors see inside the human body without cutting it open. We even use it to study earthquakes. Pretty amazing stuff.
And that brings us right back to the beginning, full circle. We have all the pieces of the puzzle now, right? We know what they are, how they travel, and most importantly, we know about their insane difference in speed. So let's put it all together and finally answer that question about lightning and thunder.
So here it is. The lightning flash and the thunderclap are created at the exact same time and in the exact same place. But the light from that flash, being an electromagnetic wave screaming along at 300 million meters per second, it gets to your eyes pretty much instantly. I mean, for all practical purposes, it's immediate. Meanwhile, the sound of the thunder, that mechanical wave, it has to physically push its way through all the air molecules between the storm and you, chugging along at just 343 meters per second. It just takes way, way longer to finish the trip. Simple as that.
So if there's one thing to remember, it's this. Light is like the universe's super-fast, rapid-fire messenger. It can cross the entire cosmos. Sound, on the other hand, is more of our local, intimate messenger. It has to rely on the world right around us to carry its message. Both of them, light and sound, are absolutely vital. They create this incredibly rich sensory world that we live in. Which kind of leaves us with one last thought to chew on. From gravity holding you in your seat to magnetism, what other invisible forces are out there shaping your world right this very second?